So today we're going to be starting Unit 7 by graphing radical functions, and then we're going to be adding in some transformations at the end today, or just after we graph the parent functions. We're really going to focus on graphing the square root today, also things to the 1/2 power. So um, something in parentheses to the 1/2 power or something to the 1/2 power is the same thing as taking the square root of something. So they mean the exact same thing. It's good to know that they're equivalent. So when we see either of those today, just mean that they mean the same thing. We're just basically taking the square root of x or whatever's inside the parentheses being taken to the 1/2 power. So the way we graph square root functions is we do it similar to the way we graph linear or quadratic or absolute value. We first graph our parent function, then we kind of shift it around and make transformations on that based on what the equation tells us to do. So the first thing we're going to do right now is graph the parent function of the square root of x, or if you notice it says x to the 1/2 power, they mean the same thing. So this is the parent function. Now, the parent table is very important to note too because it tells us the exact points that we're going to graph for the function. I'm going to go ahead and create it right below here under where it says parent function. So I'm going to create a little XY table, and I'm going to do it horizontally because there's not enough room to do it vertically. And you can do this vertically or horizontally, it doesn't matter. So I'm going to create this little XY table with some values. And as I go through, I'll kind of separate them. So the points that I'm going to plug in for my x values are going to be points that I can easily take the square root of. So things like 0. The square root of 0 is 0. The next one would be 1. The square root of 1 is 1. I can also take the square root of 4. I get 2. And I can also take the square root of 9 and I get 3. Those are the only points that we need to graph for our parent function. And if you noticed, I only picked numbers that I could fit on this graph. And the reason I couldn't pick anything negative was because we can't take the square root of a negative number. So it doesn't work. We can't graph those values. So I only picked 0 and then positive values for my x. And that's what the parent function is. So I'm going to go ahead and graph these points. I start at 0, 0. Then I go 1, 1, 4, 2, 9, 3. So here's my parent graph of the square root of x. And there's my parent table. Very important. If you don't know how I got this or you still don't understand it, you just need to memorize it. So you will need to memorize this in order to perform transformations as we get through more examples in this in the notes. So yes, we're going to perform transformations on this parent table, so you have to know those points. I would memorize them. All right, so making transformations. As we go to the second example, it says f of x equals the square root of x plus 2 inside the radical, and then we have a minus 1 on the outside. So getting into transformations, something very important to note is that everything inside the radical affects our x values. Everything outside of the radical affects our y values. So I'm going to go ahead and make that up here. Everything inside the radical affects our x values, and everything outside the radical affects our y values. So that's very important as we look at these transformations and we graph these new functions. For example, this one, we have x plus 2 inside the radical. So that x plus 2 is going to affect my x values of my parent table. Now, if you remember from quadratics and things like that, everything inside lies. So I'm going to actually take the opposite of x plus 2 and I'm going to subtract 2. So what we're going to do is we're going to look at everything being transformed. I'm going to have this x plus 2, I'm going to subtract 2 from my original x values that are located right here. I'm going to take all those x values, subtract 2 from each one of them. I'm going to create a new table here. Might get a little cramped, but that's okay. So I'm going to take 0 and subtract 2. I get negative 2. Then I take 1 and I subtract 2 and I get negative 1. I'm looking at these x values right here. Then I take 4 and I subtract 2 and I get 2. 9 minus 2 gives me 7. Now let's look at my y's. I have a minus 1 on the outside of my radical in the equation, meaning I'm going to take all of my y values and subtract 1. So looking at my y values, 0 minus 1 is negative 1, 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2. So now I have my new table, and I can just graph those points. That is the parent function transformed based on this equation. So negative 2, negative 1, negative 1, 0, 2, 1, 7, 2. Connect those dots, and that's what my square root function looks like. If you notice, the square root graph has a distinct little curve. It starts at one point and it kind of curves off to the right there. So that's what it's always going to look like. It's just going to be shifted left or right, up and down. Horizontal transformation and vertical transformation, let's go ahead and describe those. From my parent function, I shifted to the left 2, and that comes from the function, like the equation they gave me. Inside the radical, I had x plus 2, which means I subtracted 2 from my x values. So horizontal transformation, I went left 2. Vertical transformation, I went down 1. Again, that comes from that plus 2 minus 1 in my equation. The next example, I have f of x equals x minus 2 to the 1/2 power plus 4. So we're going to do the exact same thing again. Based off of my parent table, I'm going to create a new table. Okay, now it depends on what these transformations say. Because I have an x minus 2 on the inside of my radical, or in this case my parentheses, which this is actually just the same thing as saying the square root of x minus 2 plus 4. They're saying the exact same thing. Anything taken to the 1/2 power is the same thing as taking the square root. So I have x minus 2, but don't forget, what's inside lies. I'm going to do the opposite of that, meaning I'm going to add 2 to all of my original x values from my parent table. So looking at my very beginning parent table, put a star by it, I'm going to add 2 to all of those x values. So I get 2, 3, 6, 11. Now for my y's, anything affecting it on the outside of that radical or the parentheses, yes, I have that plus 4, meaning I'm going to add 4 to all of my original x values. I get 4, 5, 6, and 7. Okay, let's graph these new points now. Over 2 up 4, over 3 up 5, over 6 up 6, over 11 up 7, which would be somewhere over there. If you can't graph it, that's okay, as long as you can fit all of those on your graph. Okay, so horizontal transformation, I shifted to the right 2, remember opposite of whatever my transformation was there. So I went right 2, and then I went up 4, based on my transformations on my y's. All right, moving on to target 2, we're going to actually do the same thing, except we're going to add a couple more pieces to it. We're going to find the zeros, the domain, and the range of all of these square root function graphs that we've been doing. So we're going to do 2 more. I'm going to write the parent table off to the side again, just so we don't forget it. I would recommend doing this right when you get your paper. So x values, positive numbers that I can take the square root of easily, 0, 1, 4, and 9. And the y values are just the square roots of those numbers. So 0, 1, 2, 3. All right, now I'm going to actually transform that parent table and make it a new one. So I'll write my new one off to the side here, and let's see what that's going to look like. Am I doing anything to my x values? Is there anything going on inside the radical? Yeah, I have an x plus 2 in there, which means I'm going to take the opposite of that and subtract 2 from all of my x values. So I'm going to do 0 minus 2 is negative 2, 1 minus 2 is negative 1. 4 minus 2 is 2. 9 minus 2 is 7. And then my y's. I have a minus 3 outside my radical, meaning I'm going to subtract 3 from all those y's. Now we don't change the sign on the y transformations, we only do the opposite with the x's. So we're actually going to do the exact what it says. This stays true, we do the opposite of the inside the radical. So 0 minus 3 is negative 3, 1 minus 3 is negative 2, 2 minus 3 is negative 1, 3 minus 3 is 0. And let's graph these new points. So negative 2, negative 3, negative 1, negative 2, 2, negative 1, 7, 0. Here's my square root graph. All right. Now, domain, range, and zeros. We know how to write domain and range of pretty much everything. We know how to kind of look at a graph and determine what that means. A domain is just looking at all of my x values and thinking, what possibility do I have? How many x values am I including in this graph? My range is going to have to do with my y's. So looking at this graph, what x value am I starting at, and then am I going forever in one direction possibly? Yeah, the x value that I'm starting at is negative 2. It's right here. So, and I have everything bigger than that because that arrow means I'm including every single x value to the right. So my domain is x is greater than or equal to negative 2. I'm including negative 2 and everything bigger than that. My range, what y value am I starting at and where am I going from there? I'm starting at negative 3 and I'm going up from there, which means I'm including every y value above 3. So y is greater than or equal to negative 3. And then my zeros. Now my zeros are going to come from wherever my graph crosses, or wherever my square root graph crosses the x-axis. So wherever the graph crosses the x-axis. And it actually crosses right here at positive 7. So I'm going to say it crosses and I have a 0 at x equals 7. You just have to write the x value that it crosses at. And then finally we'll do our last example here. Don't forget that anything taken to the 1/2 power is the same exact thing as writing it as the square root of x minus 2 plus 1. All right, my new table, let's think. What is going to affect my x values? Anything inside there? Yeah, and I have to do the opposite of that. So I'm going to take my original x values from my parent table, which is way over here, and I'll add 2 to all those x values. So I get 2, 3, 6, 11. And then what's going on with my y's? Well, taking all my original y's and I'm adding 1. So 1, 2, 3, 4. All right, let's graph those new points. 2, 1, 3, 2, 6, 3, 11, 4 would be somewhere over here. And that's that. All right, domain. What x value am I starting at? Let's see, I'm actually starting at the x value of positive 2, and I'm going to the right of that. So I'm including every x value greater than or equal to positive 2. Let's look at my range. What y value am I starting at? I'm starting at the y value of positive 1, and I'm including everything bigger than that. So y is greater than or equal to 1. Question, do I cross the x-axis at all in this graph? No, I don't, and I never will. I'm going to keep going up and up to the right. After this, I start above my axis and I will never come back down to it. So my zeros, in this case, I have none. And there will be times where that happens as long as your graph doesn't cross in the graph that you drew. So like I don't see any crossings in front of me. It's never going to come back down and cross like at a later time. So just put none for that. It never crosses the x-axis. All right, and that is it for the notes over targets 1 and 2. If you have any other questions, don't hesitate to ask your Algebra 2 teacher.